Let us continue with one more example. Here we will be applying the converse of BPT, not the BPT exactly. Question goes like this. There is a triangle PQR where ST is drawn in such a way that it divides the two sides, that is PQ and PR, okay, proportionally, like PS by SQ. I'll write it down. Given is PS by SQ is equal to PT by TR or PT by RT, okay. This is given. And further, it also says that you can see in the diagram, two angles are marked equal. That is, one is angle PST. Angle PST is equal to angle PRQ. Angle PRQ. Now, they have asked us to prove that triangle PQR is isosceles. How do you say a triangle is isosceles? Just prove that its two sides, opposite sides are equal, or two opposite angles are equal. Any two angles or two sides. Here it will be very easy for us to deal with the angles because already they have given a connection among angles. Sides, they have not mentioned any lengths. So we will not be going with the sides. We will try to take advantage of the angles that is given. Okay, so how do we go through this? First of all, let us look at the solution now. Given is PS by SQ, that is first part upon second part, is equal to PT by RT, which is again first part upon second part. Try to remember that, right? So first part by second part. If the sides are proportional, then we can say that the line is parallel to the third side. So the line here is the ST line, which is dividing. So we can say ST is parallel to QR by not the theorem but the converse of the theorem. So we can say ST is parallel to QR because of the converse of the theorem. Converse of BPT. Because of the converse, we can say the lines are parallel. Once you talk about parallel lines, I hope you remember, if two lines are parallel and a transversal is drawn, then the corresponding angles drawn will be equal. There are four sets of corresponding angles, however. Here one is there, that is one pair. So now two pairs are already marked. Third pair, that's marked, and the fourth pair. So there are four pairs of corresponding angles. We will be needing only one of them. So if I take a part of the picture out of there, let me draw that separately. Observe this, PSQ, that line, P, okay, S is a point, Q is a point, ST is a line, QR is a line, right? Once they are said to be parallel and this PQ line acts like a transversal, then what about these two angles? They are nothing but corresponding angles, PST and PQR. They both are corresponding angles. So corresponding angles must be equal. So which are the corresponding angles here? PST and PQR. These two are corresponding angles. So I can write angle PST is equal to angle PQR. Reason? They are corresponding angles. Once you say the lines are parallel, then you can go for corresponding angles. So you got the corresponding angles. I'll call this equation 1. Now look at what is given. PST is also equal to PRQ. Okay, I'll write it once more. PST is equal to angle PRQ. Why is that? Because it is given. Because given. I'll call this as equation 2. Now compare equation 1 and 2. Left hand sides are equal. That means right hand sides must be equal. What are the right hand sides? Angle PQR is equal to angle PRQ. So we can just mention from 1 and 2. We can write angle PQR. PQR is equal to angle PRQ. If those two angles, PQR is this one PRQ is this one. If those two are equal, that means the triangle is a isosceles triangle.